And so now we have two functions that will check for us if this function, if this list has equal diagonal sums, right? Now they are separate. They're checking from left, and then this one's checking from right. So let's create a function that's going to use the two of them to check to see if this list has equal diagonal sums. Okay, now we're checking to see if it has equal diagonal sums. We're going to call these two functions in there. Let's create a function and let's call it has equal diagonal sum. Okay, sums, because it's more than one. All right, so the idea here is we're going to say, we'll figure out what parameters we're going to pass here. But the idea here is, let's just get rid of this. The idea here is this. If, okay, it has equal from left diagonal sum, and then it has equal from right diagonal sum, then it should return true. This function will return true. That means it has equal diagonal sums, right? So that's what we're going to do. So if it has equal from left diagonal sum, the list. Now this function needs certain arguments, right? Again, we'll break these lines very soon. But it needs to use a two-dimensional list, which means our function has equal diagonal sums also. Just shift this down a little bit just so it's clear. Which means this function also needs our two-dimensional list. I'm going to pass it to I'm going to define a parameter for this function and make it available to this function as well. Now our has equal from left diagonal sum function also needs our length of any row or column. So I'm going to define a parameter for our has equal diagonal sums function so that it's available to our has equal from left diagonal sum. It also needs our first row sum. I'm going to make that available by defining it as a parameter for our has equal diagonal sums, sum function. And then I'm also going to make it available. So it's available to our has equal from left diagonal sum. Right, so if it has equal from left diagonal sum, okay, and at the same time it has equal from right diagonal sum. See? Alright, so it's exceeding the line here. I'm going to break it somewhere around here by typing in a backslash and hit enter. So let's continue. Don't worry, we'll continue to break it. So if it has equal from left diagonal sum and it has equal from right diagonal sum, now how it has equal from right diagonal sum needs the user two-dimensional list, which is already defined as a parameter here. So let's make it available to this function by passing it in. It also needs our length of any row or column, okay, which we have here already available. So let's pass it to this function. So let's break this here. I'm going to type in a backslash, hit enter. And over here, it also needs our has equal from right diagonal sum function, also needs our first row sum, which we have available here, so we can pass it to this function. Okay, so we are passing this line to, I want to break it somewhere around here. Type in a backslash, hit enter. All right, so if has equal from left diagonal sum and at the same time has equal from right diagonal sum, put our colon here, then that means it has equal diagonal sum. So let's go ahead and return true. Else, that means that it doesn't have equal diagonal sum. So let's return false. Oops, false. That's it. Right, so it makes sense, right? Because we just call one function and it checks for us. It checks to see if it has equal from left, equal right, from right. This will deal with it. If it has both equal from left diagonal sums and equal from right diagonal sums, then we return true. That means it has equal diagonal sums. So one function does it for us. All right, so let's just break some of these lines here. This is exceeding, so I'm going to type break it into two. Type in a backslash, hit enter. It's just visually, right? Visually, we just want to break our lines and make it compact here, just so it doesn't exceed us. So type in a backslash, hit enter somewhere around here. Break this somewhere around here, backslash enter, and then break this here, backslash enter. Do the same thing for this. Break it somewhere around here, backslash hit enter, and then that's it. Okay, so now the program over here said, write a function that accepts a two-dimensional list as an argument and determines whether the list is a Lo Shu Magic Square, right? So now let's create that function. Because we don't have to do any work because we've already written our functions to do all the internal work. So let's create a function. Let's call it is Lo Shu. Is Lo Shu. magic square. This function is going to return true or false based on whether the list is a Lo Shu magic square. All right, so if it's a Lo Shu magic square, right, first of all, it needs to have equal row and column sums, right? And then it needs to have equal diagonal sums. Where is it? Equal diagonal sums, right? So if this list has equal row sums, sorry, if it has equal row and column sums, and it has equal diagonal sums, then this is a Lo Shu magic square, right? These two functions we've called will do all the work for us, right? So it has equal diagonal sums, we'll check for the diagonal sums, and then has, where is it? Has equal row and column sums. We'll check to see if it has equal row and column sums for us. Okay, so that shows that it's a Lo Shu magic square. All right, so let's write that. So if, right, it has equal row and column sums. So it has equal row and column sums here. Right? So our first of all has equal row and column sums. Let's see what it needs. So it's equal row and column sums is right here. It needs our two-dimensional list. All right, I'm going to define a parameter for this function. So if we are doing this, then the Lo Shu magic square also needs that. It needs that so that this function can have access to it. So I'm going to define as a parameter the list for this Lo Shu magic square, and then if we are passing, or if we're defining a parameter for this function needs that parameter here. So let's continue. Has equal row and column sums also needs our first row sum. So that means I'm going to define a parameter for the is Lo Shu magic square function. Now that I pass it here, this also needs access to it. So I'm going to pass it to our has equal row and column sums. And has equal row and column sums, okay, also needs our number of rows and our number of columns. Okay, so let's do that. So number of rows, I'm going to make a copy of it. I'm going to define that as a parameter for the Lo Shu magic square function so that this can have access to it. And then also I'm going to define the number of columns as a parameter for our Lo Shu magic square function, and this needs access to that as well. So I'm going to pass it into the number of into the has equal row and column sums function. I'm going to pass the number of columns to that. Okay, so that's just calling one function. So if it has equal row and column sums, and at the same time it has equal diagonal sums, right? So we know our has equal diagonal sums also needs some arguments. It needs our user two-dimensional list, which we already have defined as a parameter for our R is Lo Shu magic square. So let's make it available for this. Well, I'm exceeding this line, so let's break it somewhere around here. Type in a backslash somewhere around here, hit enter. We'll continue to break it, so don't worry. Our has equal diagonal sums function also needs our length of any row or column. Okay, so I'm going to define also that as a parameter for this is Lo Shu magic square function, so that this has equal diagonal sums can have access to it. And then our has equal diagonal sums also needs our first row sum, which we have here defined already as is Lo Shu magic square, right? So we can pass that as well. I was just thinking about it that the length of any row or columns, we can actually use number of rows and number of columns for this, but it's okay. Let's just break things up and make it clear. So this is also before we continue, I want to break this a little bit. So this is succeeding. I'm going to break it somewhere around here. Type in the backslash, hit enter, and over here I'm going to break it here. So type in the backslash, hit enter. Same for this, still exceeding. Type in the backslash, hit enter. Okay, so if it has equal row sums and it has equal diagonal sums, put our colon here, then it's a Lo Shu magic square, so return true. Right? Oops, return true. else that means it's not a Lo Shu Magic Square, so return false. And we're done with our functions. Really, these are the functions that do all the dirty work, all the internal work. But in this is Lo Shu Magic Square function, we just call these two. If it has, it makes sense. If it has equal row and column sums, and it has equal diagonal sums, both from left and right, because that's what the has equal diagonal sum. That's what the has equal diagonal sums function can do for us. It checks for that for us, and has equal row and column sums. It checks to see if it has equal rows and columns rows and columns sums. It checks both, whether it has equal rows and equal columns. So these two functions do all the work for us. And then it will return true or false whether this is true, whether they're all true, or return false whether it's not a Lo Shu Magic Square. Okay, so now we can work on our main function. We have our two-dimensional list already. All right. Now the program set creates a function called one function that will just take in a list. Okay, we could have done that. We could have created a function that would just take in just a list. Right. We could have done that. But I don't want us to keep writing code to do things over and over again, right? That's why I'm providing these numbers. Now, we could have written code inside of this function to get the number of rows, to get the number of columns, but it will require us calling these functions over and over again in each of these. It requires, calling certain functions over, and I don't want that. But if you do this, then you can call functions at least once or so, maybe just once. It kind of speeds up your program a little bit because you already have the values. So all you have to do is just pass them around. Over here with this, we already have the values. All we have to do is pass them around. Once we call the get rows and columns function, we have the number of rows as a number. We can just pass it around instead of calling that function every time. You can, but I just wanted to mention that doing this way is also efficient. Okay, so we have our list. Now let's just start by calling our Lo Shu Magic Square function. So I'm going to call it. All right, so our Lo Shu Magic Square needs our list. We have that, so no problem. We're going to pass it to, before that, hold on one second. All right, so let's call this Lo Shu Magic Square, right? But before that, let's do if, okay? If is Lo Shu Magic Square. If it's Lo Shu Magic Square, we need to pass in the list. We'll do that. So with Lo Shu Magic Square, then let's print out the message. This list is a Lo Shu Magic Square. Else, then let's print out a message saying this list is this list is a Lo Shu Magic Square, and then this list is not a Lo Shu Magic Square. Like something like that. So let's see what this error is. Not sure why. Print. Not sure why. All right, let's just make a copy of this. Okay, so this list is a Lo Shu Magic Square, all right? And then this list is not a Lo Shu Magic Square. So if it's Lo Shu Magic Square, we know this is Lo Shu Magic Square function returns true or false. If it returns true, then it prints out this message. If it returns false, it prints out this message. All right, so we know that our Lo Shu Magic Square function needs our user two-dimensional list, which we have here. Okay, so we can go ahead and pass that into this function. But it needs more. It needs our first row sum as well. Now we had a function over here called get first row sum that returns our first row sum, right? So in our main function, we can call that function right under our list, get first row sum. Let's see what it needs. Get first row sum needs our user two-dimensional list and our number of columns, right? So get first row sum needs our the list and then a number of columns. In order to get a number of columns, we need to call our get rows and columns function. So let's do that because we don't have the value to pass to this function. So let's just hold on there right above this. Let's call get rows and columns. The get rows and columns function, it takes in our user two-dimensional list, right, which we have here. So I'm going to pass that into this function. And now we know our get rows and columns function returns the number of rows and the number of columns, 2 items. So that means that it's returning them respectively. It's returning the number of rows first and then the number of columns next. All right, so we need 2 variables to receive them too. So get rows and columns, it's first returning the number of rows. I'm going to create a variable to receive that number of rows. And I'm going to separate that with a comma. And I know another value is coming, which is number of columns, so I'm going to create another variable called number of columns. And that those 2 variables are going to receive those 2 values that are coming respectively. The first number that's coming is our number of rows. Second number that's coming is our number of columns. So since the first number that's coming is the number of rows, it will be stored here in the first variable that I also put here. It comes respectively. Since the next number that's coming from this function is the number of columns, I create another variable, okay, separating this with a comma, that's going to receive the next value. So now we have the number of rows and number of columns. Again, it doesn't matter, you're using the same names. The scope of these variables are within the main function, and the scope of the variables in these other functions are within their respective functions. They are considered different because they are in different functions. Now, let's get back to our get first row sum. Our get first row sum needs our easy 2-dimensional list and our number of columns. So our get first row sum needs our list, which we have here. We can pass that. It also needs our, right, let's see, get first row, it needs a list and needs a number of columns. So it needs our list and a number of columns, which we have here. So now we can pass it. And we know that our get first row sum returns the first row sum. So I'm going to create a variable to receive that value. So I'm going to create a variable called first row sum to receive that first row sum. Okay, so now we have our first row sum. It doesn't matter, again, the name is the same as these names. They're considered 2 different names, 2 different variable names because they are in different functions. They're not the same. They don't see each other at all. They're like twins, but then they're not the same. Okay. So, I mean, the names are like twins, but they're not the same. Okay, so we have our first row sum. Now let's see what we need to do next. It's Lo Shu Magic Square needs our easy 2-dimensional list. It needs our first row sum. Now we have it. So we can pass this value to this is Lo Shu Magic Square function. Our is Lo Shu Magic Square also needs our number of rows, which we have here. So we can pass it also into this is Lo Shu Magic Square function. And then it needs also our number of columns, which we have here. So we can also pass that. It also needs the length of any row or column. Now in our function, we could have used these 2 values. Doesn't matter, but the length of any row or column is basically, we already have it as number of rows or number of columns. This is the length of the rows, this is the length of the column. You can use any of them. We can use any of them, actually. So what I'm going to do is I'm going to create a variable. Although, like I said, we can use these numbers directly. We can pass it. We can pass number of columns, number of rows as another variable to represent the length of any row or column. But let's just make things a bit clear. So I'm going to actually create a variable here with the same name, length of any row or column. Doesn't matter, the names are the same. Again, they are considered 2 different variables because they're in 2 different functions. Okay, so length of any row or column is going to be equal to either the number of rows or number of columns. It doesn't matter which one. I'm just going to use the number of rows because they're all the same. 3, 3. They're all the same. So I'm going to use the number of rows, and then now I have the length of any row or column because our is Lo Shu Magic Square function needs it. It needs the length of any row or column. I have it here, so I'm going to pass it to this function. And then that's it. That's all it needs. We've provided to this Lo Shu Magic Square. It's now going to print out whether this list is a Lo Shu Magic Square or it's not. This list over here. The good thing is we can change the values to see if it works or not. So we know perfectly well that this list is Lo Shu Magic Square, right? If you add these, I hope I didn't change the numbers. If you add these numbers, they are all 15. If you add this, add this, add this, add this row, add this row, add this row. This row is 15, this row is 15, this row is 15. 276 also is 15, 951, 15, 438, 15, 258 is 15, 451 sums up to 15 as well. So in this case, this is a Lo Shu Magic Square. Let's see if this program says this list is a Lo Shu Magic Square. So now all what we've done is define functions. All we've done is just define functions. When you run this program now, nothing's going to happen. Let's save this. Let's save it where we save all our programs. So Python program challenge chapter 7. This is the last program in chapter 7. So let's call it, what is it called? Let's call it Lo Shu Magic Square. So save that. Nothing happens because all we've done is just define functions. And we are not calling any function. So even though we have the main function, even though the main function is calling these functions here, right? Well, actually we are calling functions, but even though the main function is calling these functions, the main function is a function itself. And you need to call that in order to basically run all this code. So we need to call that main function in order to run everything in its in the main function. So now I call it this way. Call it by just typing main, the name of it. It doesn't need any argument. So when I run this now, I should run our program. I want to see if we have any errors. So let's just run it and let's see. All right. So it says this list is a Lo Shu Magic Square. So far it's working. So let's change this number to 1, right? Because if the first row sum 4, okay, plus 9 is 13. 13 plus 1 is 14. So it gets the first row sum 14 and says, okay, every other sum has to be equal to 14. Otherwise, this is not a Lo Shu Magic Square. So it checks 14, that's the first row sum. It has the first row sum. Starts with the first row. 14 is equal to 14. Okay, you've passed. And it checks 3 plus 5 is 8. 8 plus 7 is 15. So it says 14 is not equal to 15. Hey, this list is not a Lo Shu Magic Square. When I run the program, now it's saying this list is not a Lo Shu Magic Square. When I change this back to 2, and I run the program, and now it says this list is a Lo Shu Magic Square. Let's try another Lo Shu Magic Square, right? Let's try a simple one. Let's change all the numbers to 1. Right? So we know this is a perfect Lo Shu Magic Square, right? Because when you add this up, you get 3. Add this up, you get 3. Add this up, you get 3. When you add the columns 1, 1, 1, you get 3. 1, 1, 1, you get 3. 1, 1, 1, you get 3. And when you add the diagonals 1, 1, 1, you get 3. When you add the diagonals here from right 1, 1, 1, you get 3 as well. So let's try this. And it says this list is a Lo Shu Magic Square. Let's change one number here in the middle to, let's say, 2, right? Because now this is 3, all right, but this is 4. So it doesn't have equal row sums. It doesn't even have equal diagonal sums, right? This is 4. If you add 1, 2, and 1, you get 4. You get 4 here, all right? It has equal diagonal sums, right? But it doesn't have equal row and column sums. Like this column here is 4. This column here is 3. So this is not a Lo Shu Magic Square. So when I run this program, it says this list is not a Lo Shu Magic Square. So the program is working perfectly. And the way we've broken down things is also good, right? Because you can use it, these individual functions however you want to, even modify this program and make it even better. The beautiful thing is you can actually extend this. It doesn't have to be just a 3x3. It can be a 4x4. So we can do another one here, and another one, and then let's get one more as a comment here. Oops. Yeah, we can just break it. Okay, so this is a 4x4. Okay, 4 rows and 4 columns. This is a Lo Shu Magic Square because if you add the diagonals, it's 4. Diagonals is 4. Rows, all 4. Columns will be all 4. When I run this program, it says this list is a Lo Shu Magic Square. When I change the number, let's say 2, all of a sudden, this column is 5. This column is 5 all of a sudden. This column is 4. This column is 4. This column is 4. So it's not a Lo Shu Magic Square. When I run this program, it says this list is not a Lo Shu Magic Square. So this program works. If you have any questions, please comment down below, and I'll do everything to respond to them. Thank you very much for watching. Take care of yourselves, and I'll see you with the next program in Chapter 8, the first program in Chapter 8. All right, then. Take care. Bye-bye.